What effect does changing the sample size have on the critical region and the probability of a type 1 error? Is it A, increasing the sample size results in a larger critical region, and so the risk of a type 1 error increases? Or B, increasing the sample size results in a smaller critical region, and so the risk of a type 1 error increases? C, increasing the sample size results in a larger critical region, and so the risk of a type 1 error decreases? Or D, sample size does not influence the critical region or the risk of a type 1 error? Now the answer here is going to be D. Sample size does not influence the critical region or the risk of a type 1 error. And the reason for that is that the probability of a type 1 error is equal simply to alpha. Whatever significance level you choose for your test, that's going to be what determines the chance of type 1 error. It has nothing to do with sample size. So, for example, if I am conducting a test and I choose to go with a 5% significance level, let's say that this is a test where I'm looking for an increase due to my treatment effect, an increase to the scores. Well, then I would be putting my critical region in the upper tail, because I would be looking to see whether or not my scores land close to the untreated mean, or are they significantly higher, suggesting that maybe the treatment does increase my scores. So if I land in this critical region here, that would lead me to reject the null hypothesis. So anything that lands in here, any values or any samples that have means that land beyond this boundary, will lead me to reject the null hypothesis. Sometimes that will lead to an error. In fact, let me put it this way. Type 1 error occurs when you reject a true null hypothesis. Okay, so type 1 error occurs when you reject a true null hypothesis. Well, how would you reduce a type 1 error? Because it sounds like a bad thing. You don't want to make errors when you're conducting a hypothesis test. How would you reduce this? Well, you should reduce your chance of rejecting any null hypothesis. In fact, if you went with, instead of an alpha level of 5%, let's say you went with a much smaller one, an alpha level of 1%. You're not going to be filling in a whole 5%. You're going to be filling in only about a fifth of that. So this would be my alpha level of 1. And so I'm going to have a different boundary. It's going to be harder to find samples that actually go past that boundary. So only when I get past there would I reject the null hypothesis. By choosing a smaller alpha level, it will be less likely that I'm going to reject the null hypothesis, which means there's going to be less times that I will have rejected a true null hypothesis. We never know whether the hypothesis we rejected was true or false, but if we're not rejecting anything, then we're not making a type 1 error. So the only way to affect the chance of type 1 error, and the only way to choose a different size of critical region, is to simply choose a different significance level. It doesn't have anything to do with sample size. So D is our answer.